Alright guys, welcome to this page of the notes, and again, what we're doing here is we're working on finding composite functions, plugging a function into another function. And what we're going to do here in this case is a little bit more typical of the kinds of composite functions you see in algebra, although the previous exam problems are very important and I will put those on quizzes and tests. This is more what you would think of when coming to composite functions in algebra, where I actually give you a function for f of x and a function for g of x, and I ask you to find the composite functions. This is actually a two-part problem where I ask you to find the composite f of g of x and then find the composite g of f of x. So we're going to find both of those. And then in addition to that, I then ask you to evaluate both of those composite functions for a particular domain value. So we'll get to that in a second. We're going to start with the f of g of x, and let me show you how I would do these. Now, previously, when you had been given a domain value, you had started inside and sort of worked your way out. We plugged that domain value in, evaluated g at that domain value to get a range value, which then became the domain value that we plugged into f to get our final range value. It's not going to work that way in this case because you have been given functions. So we're going to work outside in this time. So in order to do f of g of x, I actually need to start with the function f. So here, over here, the first one we're going to do is f of g of x. I am going to plug the function g of x inside the function f of x. So, since g of x is getting plugged into f of x, I need to start with f of x, which is x plus 3. So, f of x is equal to x plus 3. Now what I'm going to do is plug g of x into f of x. So everywhere I have an x, I'm now going to plug in the domain value g of x. So f of g of x. What this means is everywhere I have an x, I plug in a g of x. Well, the only place I have an x is right here. So that's where my g of x is going to go. I'm going to plug in a g of x right there, and I still have the plus 3 on the end. Plus 3, right? So my domain value, here's my function f of x, it's x plus 3. I'm going to plug a g of x into that function. The domain value is going to be g of x. So I plug that g of x in everywhere I have an x, which is just right there. And now let's go ahead and plug in what g of x is. It's x squared plus x minus 1. So f of g of x is equal to x squared plus x minus 1, and then I still have that plus 3 on the end back there. I've just plugged my g of x inside the parentheses, so I know that's where my g of x goes, and that plus 3 is still back there. I'll now go ahead and combine like terms to get g of x in simplest form, and then we'll take a look at what I mean by evaluate. So f of g of x is equal x squared plus x, and a negative 1 plus 3 would be a plus 2. Now, what I've asked you to do is evaluate this composite function at x equals 2. I do that right here. I want you to evaluate f of g of x for x equals 2. What that means is you're going to plug in a domain value, an x value of 2. So let's go ahead and do that. So I have f of g of 2, right? Because I'm going to plug in a domain value of 2 everywhere I have an x. Well, we can do that. There's an x right there, so that's going to become a 2. So there's my first domain value, right? I plug a 2 in for x, and then I have another x right there, so plus 2, and then I got that plus 2 out here on the end. So all I've done is to evaluate x equals 2, that's the domain value that I'm plugging into this composite function. So everywhere I have an x, I plug in that domain value. We now evaluate to figure out what the range is for this composite function. So f of g of 2 is equal. Well, 2 squared is 4. 2 plus 2 is 4. And so it looks like we wind up with f of g of 2 being equal to 8. So I've actually got two answers, right? Because I asked you to do two different things. First, I asked you to find the composite function f of g of x, and that composite function is x squared plus x plus 2. That's the composite function f of g of x, where I plug g of x into the function f of x. But then I ask you to evaluate that guy, that composite function, for the domain value of 2, x equals 2. So I plug in that domain value, x equals 2, into my composite function. So everywhere I have an x, I just plug in a 2, because that's what I told you to plug in. I gave you that domain value. And when you plugged it in, we get out a range value of 8. Guys, this is exactly what you were doing when we had the ordered pairs, or when we had the graph, or when we had the table, right? This is an ordered pair. This is the x value, the domain value, and this is the range value, 8. This is what you get out by plugging this domain value into the composite function. You get out an 8. That would be our ordered pair, 2, 8. Domain, range. All right, that's not the only one. I also ask you to do g of f of x. So let's do that one right over here. Let's split this guy, divide that guy, and draw a little line there so we don't get lost. And we're going to do g of f of x. Again, what I got to do is work outside in. I'm going to be plugging the function f of x into the function g of x. So I need to start with g of x. Well, g of x is equal to x squared plus x minus 1. Now what I'm going to do is I'm going to plug f of x into that function. So g of f of x means everywhere I have an x, I'm going to plug in an f of x. Well, there's an x right there, so I'm going to have an f of x squared. There's another x, so plus f of x minus 1. Well, what is f of x? F of x, the function f of x is an x plus 3. So I'll just plug that in instead. I apologize, I may have to squeeze a little bit here. Let me erase that line so I don't... We'll just kind of curve it in here a little bit. All right, so g of f of x is equal to, it's going to be an x plus 3 squared plus x plus 3 minus 1. That wasn't so bad. I didn't have to squeeze that bad. So f of x, right, got plugged in. I plugged f of x in everywhere I had an x, there and there. But I know what f of x is. F of x is x plus 3. So I just simply substitute x plus 3 for each of my f of x's. Careful, this is a binomial and it's squared. So please be very, very careful. Property of exponents does not say x squared plus 9, right? You can't square both of those. You can only do that if they were multiplied. They're not multiplied, they're added. It's a binomial, so you'll need to FOIL these guys. G of f of x is equal to x plus 3 times x plus 3. And let's go and take care of all this. I have plus x plus 3 minus 1, which would be a plus 2. So plus x plus 2. FOIL this guy out. You're going to wind up with an x squared plus 3x plus 3x plus 9 plus x plus 2, which were already there, the plus x and the plus 2. Combine like terms. G of f of x is equal to x squared plus 6x plus 9 plus x plus 2. One more. x squared. 6x plus x is going to be 7x plus 7x, and 9 plus 2 is going to be plus 11. So there we go. There's my function g of f of x. Now I ask you to evaluate that guy. So we're going to go ahead and evaluate this function at x equals 2. Evaluate. Which means everywhere I have an x, we're going to plug in a 2. So g of f of 2 means I'm going to have a 2 squared plus 7 times 2 plus 11. 2 is my domain value. That's what I'm going to plug into my composite function and see what we get out. G of f of 2. 2 squared is 4. 7 times 2 is 14 plus 11. So g of f of 2 is going to be equal to 29. Again, that was a two-part problem where first you had to find the composite function g of f of x by plugging f of x into the function g, and then I asked you to evaluate that composite function at the domain value of 2. So you just plug a domain value of 2 in everywhere you have an x to get out your range value of 29. Again, this would be my ordered pair. The domain value would be 2. The range value would be 29. 29 is the result of the composite function. It's what comes out at the end. Guys, head on over to the next page of the notes. I have another one of these for you where we'll work through setting up these algebraic composite functions and see how it goes. So head on over to the next page of the notes and I'll meet you guys there.